Next, I'm going to teach you fraction-based calculations. So, in fraction-based calculations, what are the different topics that you have is like fractions or unlike fractions, and you have proper fractions and improper fractions, mixed fractions. These are all the three topics that you have to be concentrated about. Okay, what is meant by a like fraction? Like fraction or an unlike fraction is something you will be having the denominator of the two fractions going to be the same. If the denominator of the two fractions are going to same, we call it as a like fraction. If the denominator of the two fractions are not same, we call it as an unlike fraction. We're going to concentrate about proper fractions. A proper fraction is the one whose numerator will be less than the denominator, such that its answer will always be lesser than 1. This is a proper fraction. For an improper fraction, the numerator part will always be greater than the denominator part, whose answer will be more than 1. So this part is called as numerator, this part is called as a denominator. For an example, for a proper fraction, let me say you have a denominator as 5, like take it as 6, and numerator it as 4. If you cancel 2 2s are 4, 2 3s are 6. If you divide 3 by 2, 0.6. So the answer always goes lesser than 1. So if the numerator is lesser than the denominator, the resultant answer will also be lesser than 1. If the numerator is greater than denominator, for an example, 6 divided by 4, denominator is lesser. So 2, 3. Now you see 2, 3. 2 1s are 2, 1.0, 1.5. Answer is going more than 1. So this is called as an improper fraction. Next one, what we're going to see is like mixed fractions. So what is meant by a mixed fraction? For an example, 16, I'm dividing it by, let's take 7. Obviously, we won't get a complete real number answer. Complete number we won't get, because 60 is not going to be divisible by 17. Definitely will make into a mixed fraction. When this mixed fraction exists, when a number is not divided by its own divisible. For example, 60 will be divided by 2 table, 3 table, 5 table, 6 table. Apart from these tables, if you try to, when you even in 4 table, 60 is divisible, right? So in these, apart from these tables, when you try to divide 60 by any other number, it will lead you with mixed fraction result. For example, 7, 60. Same, you take 60 by 4. If you divide 60 by 4, 4 1s are 4, 20, 5. So you will get a remainder 0. The answer will be 15. But if you divide 60 by 7, you won't get a complete result. For example, 7 table. So if you take in the 7 table, so if I deal with 60, 7 8s are 56. The remainder will be 4. So from this, how you will be writing a mixed fraction? A mixed fraction is nothing but this part comes this side and this part goes that side. So what will be the quotient? 8. This quotient 8 should go towards the sideward, remainder will go in the upward, and divisor will come in sideward. So this is similar to 8. This is nothing but a quotient. Upper part should be a remainder and lower part should be a divisor. If you forget how to align this, please remember this cube r by d. So q is a quotient, r is a remainder, d is a divisor. So this is how you will be expressing any mixed fraction. So like fractions, unlike fractions, proper fractions, improper fractions, and mixed fractions. These are the important 3 classifications of any fraction. Now let's see how to do the calculations based on this. And again, from this mixed fraction, you can bring this to a normal form. How we can make it? We have to multiply both of this, converting a mixed fraction into a proper fraction. This is called as a proper fraction. This is called as a mixed fraction. 8 7s are 56. 56, we have to multiply both of these, 8 into 7, and you have to add this 4 to that. So 56 plus 4 will give you 60, right? So how we will be expressing it? 60 divided by this 7. So mixed fraction, we have to multiply and we have to add and we have to place the divisor part in the downward. Okay, so see how to tackle some problems based on this. Okay, Now I'm going to solve you some problems. Let's imagine 1 by 2 plus 1 by 2. Okay, in this scenario we have both the divisor same, they are proper fractions. When you add a proper fractions, what is meant by a proper fraction? A proper fraction means denominator will be the same for any two fractions, or I can add any three fractions also, like we have 3 by 2. So when you have the denominators same, you can take the denominators as common. Okay, then you have to write 1 plus 1 plus 3. So 1 plus 1 is 2, 2 plus 3 is 5, so I get 5 by 2. If you divide this, you will get 2.5. Got it? Again, if you given any decimal value, if you want to convert a decimal value to a fraction, if they ask you to convert a decimal to a fraction like 2.5, after point how many integers are there? One integer. Then you have to divide by, then you have to multiply and divide by 10. After point, if you have one decimal, multiply and divide by 10. If they ask you to convert a decimal to a fraction, after decimal, if you have two digits, then you have to multiply by two zeros, 1 into 100. So you will get 25, like 255 this is. So 255 divided by 100. Then if you do a simplification, you will get a fractional part. Okay. So this is how you carry over with the addition with the proper fractions. Now let me see how we have to tackle the calculations for unlike fractions. Unlike fractions are those who have their denominators different. Okay, again you can also say this is a proper fraction because denominator is greater than the numerator, and this is an improper fraction because denominator is higher than the numerator. But now you don't want to bother about improper or proper fraction. It's just an information for you. You're not going to make any sense with this improper and a proper fraction, but do aware with this like fraction and unlike fraction. This is like fraction, this is an unlike fraction. Again, if we have these kind of different denominators, first we have to go for LCM. So how we will be calculating the LCM for 4 and 8? 4, 8. So I can start by 4 table itself. 4 ones are 4. That is like you can start from 2 table, you can start from 4 table. The result is going to be the same. 4 ones are 4, 4 twos are 8. Then in 2 table, 1 1. Okay. If you are starting from HCF, you can go from the scratch. For an LCM, you can begin with the highest factor. That is not going to make any bad impact. So I'm taking directly with the 4 table. 4 ones are 4, 4 twos are 8, 2 ones are 2, 2 ones are 2. So the LCM will be 4 into 2. That gives you 8. Next thing, you have to multiply the numerator and the denominator to make the outcome of the LCM. So here I have 1 by 4. So in what table 4 should be multiplied to get 8? It's 2. 4 2 are 8, and same 2 you have to multiply upward, plus 5 by 8. What should be multiplied with 8 to get 8? 1. So 1 1. So the output will be common 8, because here also we have received 8, here also we have received 8. Now they are converted into a like fraction. So common 8 we can take. If you are confused with this step, I can write like 1 by 8 plus 5 by 8. Now denominators are same, so it is a like fraction. So when I receive a like fraction, I can place 8 here. So 1 plus 5, that gives you 6 by 8. If you simplify this in 2 table, I can get 2 3s are, 2 4s are. So the answer of 1 by 4 plus 5 by 8 is 3 by 4. On similar way, if they are given negative, you have to do a negative operation. That's it. Now let's see another sum. Now what I'm going to do is minus 1 by 4 minus 5 by 8. Now I have given a negative integer. As we know, LCM of 4 and 8 is 8. So we have to multiply this by 2, this by 2. So like minus 1 divided by 4 into 2 into 2 minus 5 by 8 into 1 into 1. So we know the LCM is of 4 by 8 is 4 1s are 4, 4 2s are 8. So as I mentioned already, it's 8. Okay. Now the result will be like minus 2 divided by 8 minus 5 divided by 8. Now I have made it as a like fraction. So minus 2 and minus 5. So minus 2 minus 5. This is not in a multiplication sign. So 2 and 5 should be written. Both are minus. If both are minus, operation should be addition. So 7. And what is the symbol for the highest number? It is negative. So minus. When we have 2 minus, we have to do the operation addition. Symbol, highest number symbol, that is negative. So minus 7. So minus 7 by 8 will be the answer for it. Now I am going to teach you fraction based multiplication and fraction based division. Now if you are going to multiply two fractions, again the same rules exist. 2 negative, if you multiply, you will get positive. 2 negative, if you are going to apply the same rule, operation should be addition, symbol should be negative. So what are the rules that are given for integers? Same thing will be applicable here. For an example, minus 1 by 2 multiplied with 1 by minus 2. Here you can see, even though if you have the symbol, negative symbol in the denominator, you can move it to the upper area. So this part can also be written as minus 2 into minus 1 by 2. This symbol can be moved upward if you have a symbol in the denominator. So minus into minus will give you plus. If you multiply both these denominator, you get 4. It will be like 1 by 4. That will be one scenario. And in another scenario, let's imagine minus 1 by 2 multiplied with 1 by 2 minus plus, obviously the result should be in minus. 1 into 1 is 1, 2 into 2 is 4, right? Next, see how to tackle this kind of multiplications. Like we have minus 3 by 4 multiplied with 6. If there is nothing in the denominator, you should assume it as 1. Okay. Again, these things will be seem very childish to those who have solved various maths problems, and this is for those who are like they lost the touch with maths, or like they are a beginners. So for those people and those who are from an arts background or diploma background with less number of maths oriented subjects, for that kind of people, this is very important. It's like a brushing up their skills. So 2 2s are 4, 2 3s are 6. You have to cancel like numerator and denominator from the common tables. Then I can write minus 9, minus 3 into 3 divided by 2. So this is how I will be denoting when I don't have any numerator part. Okay, so this is how you normally make a matrix, fraction multiplication. So normal integer rules apply. When you have a fraction, how you can do the simplifications, and if you don't have a denominator, you can assume it as 1 blindly. Okay, still I can solve you one more sum. Like imagine 50 divided by 6 into 8 divided by 4. Simply don't want to multiply, you can do simplifications in fractions. For an example, if I take 2 table, 2 3s are 6, 2 4s are 8, 4 gets cancelled, then I get 50 by 3. Okay, now for division oriented, so in division oriented problems, let's imagine A divided by B divided by C divided by D. Upper part also are going to have a fraction, lower part also are going to have a fraction divided. In that scenario, you can make it as A divided by B as it as. This C by D should be taken in a form of reciprocal. Reciprocal means it's nothing but a transpose. So D divided by C. So the output will be AD divided by BC. Same integer rules going to apply here. Let's see how to tackle the sums. In scenario number 1, minus 1 by 4 divided by 6 by 12. How we will be tackling this sum? You can cancel within this if you require. That's not going to make any issue. So minus 1 by 4, we have to put multiply. Transpose of this will be 12 by 6. 4 3s are 12. 3 1s are 3. 3 2s are 6. Minus 1 into 1 will give you minus 1. Answer will be 2. This is one of the scenario. In next scenario, what I can write is like one part will be in a fraction. Like say minus 3 by 5 divided by 20. In this scenario, how we have to transform these kind of equations like For this is in a form of a by b divided by not c by d, only c. In that scenario, you can make the result as a divided by this b part will come down with c, bc. Same, minus 3 divided by 5. This 5 will come down into 20. So minus 3 divided by 100. So you have to know two things. A by b divided by b by c will give you a by b multiplied with like let me c by d. So this will be taken as a transpose. So ad by c. On another note, a by b divided by c will give you a divided by bc. So these two formulas you have to keep in mind in order to rearrange these kind of fraction divisions. So thereby I have solved how to tackle the problems on fraction based addition for proper fractions, again for improper fractions, again how can we solve multiplications and division for fraction oriented sums. Again I am going to give you an insight over mixed fraction also. If any kind of problem that comes for a mixed fraction, say 6 1 by 2 plus 3 1 by 2, first we have to convert it into a proper or a improper fraction. 6 into 2 will be 12, 12 plus 1 will be 13, so 13 by 2 plus 3 into 2 will be 6, 6 plus 1 will be 7 by 2. Then you can do with the normal addition or subtraction or multiplication or a division oriented calculations. So thereby fractions are over.